All right, thanks, Bernard. Thanks everybody for coming, especially because I'm told today is a holiday in parts of Europe. This is a joint project with my colleague, Ron Siegel. This is basically a model that we have developed to study cooperative theory of market segmentation by consumers. We have some results too, but it's quite preliminary. So if you have any thoughts and feedback, we'll appreciate knowing those. So this is a paper about market segmentation. So let me start by defining what I mean by market segmentation. That's when a seller can divide a market of consumers into different submarkets, or you can call them segments, and offer each market segment a different price. So a seller may be able to do so by using observable characteristics of consumers like their age, sex, or in this example, their geographical location, to divide them into the different segments. So northwest, northeast, southwest, and southeast. There's already a very large literature that studies what are the effects of market segmentation. How does it affect total surplus, efficiency, consumer surplus, and so on. So this literature typically takes a segmentation as given and asks, well, under what conditions would this segmentation, for example, increase consumer surplus or efficiency total surplus? What we do in this paper is to ask, well, where do segmentations come from? In other words, we are trying to develop a positive theory that would explain or predict what kind of segmentations we should expect to arise. Now, short answer is that that's complicated because the segmentation depends on many different factors. It depends on what information the seller has available and can use for price discrimination. This information may come from different sources. Maybe the seller buys this information from third parties, or some of it is maybe voluntarily revealed to the seller by consumers who choose to let the seller know about some of their characteristics. And there's, of course, technological or legal constraints as to what kind of information the seller may be able to use for price discrimination. So in order to answer this question, we're going to make a couple of simplifying assumptions. First of all, we're going to abstract away from all these technological and legal constraints. We're going to assume that all possible segmentations are feasible, meaning every possible way to segment your market into different sets of segments is feasible. Second, we're going to take two extreme views. We're going to say, well, what would happen if the seller could choose a segmentation versus what would happen if the consumers could choose a segmentation? The case where the seller chooses is easy. The seller would basically perfectly price discriminate. We basically put every single consumer in a different segment and offer that consumer their willingness to pay for the product, if that willingness to pay is above the cost of producing the product. This is perfect price discrimination. It's going to lead to an efficient allocation, but it's going to give zero surplus to consumers. Each consumer pays their willingness to pay for the product. What would happen if consumers choose? And let me point out a difficulty in answering this question, which is that now we're talking about multiple agents choosing something, here the segmentation. And these agents, consumers, may have different preferences over different segmentations. Whereas before, the question was relatively easier. There was a single agent, the seller, who is choosing the segmentation. And of course, the seller can just choose a segmentation that gives more profit to the seller. So then, what does it mean for consumers choosing? And let me just point out this issue with different preferences over different segmentations. So let's suppose that we're comparing two different segmentation, an east-west segmentation versus a north-south segmentation. You will see that consumers in the north, they prefer the north-south segmentation because they get a price of 1 here versus in a east-west segmentation, they will either get a price of 2 or 3 if they're in the north. On the other hand, consumers in the south prefer the east-west segmentation because in this segmentation, they get a price of 4 in the other segmentation, they either get a price of 2 or 3. So consumers have different preferences over segmentations. So the way we model this question is, as the title of the project suggests, we model this as a cooperative game played between consumers. So we consider each segment to basically be a coalition of consumers. So in this example, there is one coalition, consumers in the West. There is another coalition, consumers in the East. And a segmentation is basically a partitioning of all consumers into a set of different coalitions. And then we ask, which segmentations are stable? In the sense that there would be no group of consumers who could benefit by forming a new segment and thereby maybe decreasing their price. For example, we would say that this segmentation is not stable because this consumers in the North would benefit if they form a new segment in which they get a price of 1, whereas what they're getting here is either 2 or 3. Now, exactly what the definition of stability is, I'm going to define that later, but for now, just think of it as a notion that it's immune to deviations by groups of consumers.
Can I ask a quick question? Is the same true if you consider multiple sellers?
You could ask this question with multiple sellers, but we don't. But you could ask that question. And let me point out some other. I will talk about the single seller in this throughout this talk, but notice that it doesn't really matter if there's a same seller who is serving these two markets, or there's one seller for the West and one seller for the East. So in some sense, it doesn't really matter. As long as there's a single seller for each segment, everything remains the same. So let me put this question into context. Why are we asking this question? So our work relates to the ongoing debate about consumers' control over the data. Should consumers have control? To what extent should they have control? And in what form should they have control over the data that they reveal to sellers? The literature has already observed an issue, which is the collective action problem. What is this issue? There is an externality when a consumer chooses to reveal their data to a seller. We call this the data externality. What is this data externality? For example, imagine that you're a student, and students tend to have low willingness to pay for products because they're more poor. If you reveal this information to a seller, you show your student ID, you may be able to get a lower price for the products that the seller is selling. But once you do this, the price for other consumers may go up because they are now less likely to be a student. This was a case of a negative externality. If I reveal my data, the price for others may go up. The literature has also identified scenarios under which the externality may be positive. The sign doesn't really matter for us. What matters is that there are some externalities. And as long as there are externalities in a consumer's decision to reveal their data or not, we are going to have a collective action problem, meaning that the equilibria, once agents individually decide whether or not to reveal their data, they are going to be inefficient. So in light of this issue, the collective action problem, there has been calls for some kind of collective action. So data collectives or data intermediaries who would act on behalf of consumers and facilitate some kind of collective decision-making process for consumers. So you could imagine there would be a website in which students can go register on that website by showing proof that they're students. And on that website, they can get cheaper prices for different products. And you can think of our question as basically asking, so then what would happen if such data intermediaries exist? What would happen if consumers could jointly choose a segmentation? So notice that we are not taking away the externalities problem. Externalities still exist. If all students sign up on this website, and they get cheaper prices, the prices to everybody else may go up because now everybody else is not a student. What we are doing is allowing consumers to make these joint decisions via possibly these data intermediaries. So let me just preview the kind of results that we see. We're going to see that the stable segmentations are going to be efficient. So this would be unlike the case of the individual decision-making problem. There is going to be some price discrimination. So different consumers are going to pay different prices. And this is to some extent similar to the case of a perfect price discrimination, but the dispersion is not as much as a case of a perfect price discrimination. Consumers are still going to get some positive average consumer surplus, meaning the prices are going to be generally below their willingness to pay. But we're going to observe that consumer surplus may not be maximized in stable segmentations, meaning if you calculate the consumer surplus in a stable segmentation and ask, well, what is the maximum possible consumer surplus across all possible segmentations? The consumer surplus in a stable segmentation may be lower than the maximum consumer surplus. So basically, by allowing consumers to choose a segmentation, we are going to have efficient allocation, but not necessarily maximize consumer surplus. This is just an overview. Of course, I'm going to get to the details of how this happens. So this is basically my short introduction to the paper. I'm happy to take questions. Otherwise, I'll talk about the model.
I don't see any questions. Go ahead.
Cool. So I will basically tell you the model with examples and pictures. So I'm not going to formally define everything, just show you pictures and such. So I'm going to have to basically define these core concepts: coalitions, segments, and segmentations. So suppose that there is a unit mass of consumers uniformly distributed on the interval 0 to 1. Each consumer has a value for a product. So I should have said there's a single seller who is selling a single product. So these values are the values of consumers for this product. So in this example, consumers from 0 to 0.4 have value 1 for the product. Consumers from 0.4 to 1 have value 2 for the product. So these consumers are uniformly distributed, which means that basically a measure of 0.4 of consumers have value 1, a measure of 0.6 have value 2. So you can read these measures off the picture because consumers are uniformly distributed. So I'm not going to tell you explicitly what these measures are for the rest of the talk. So more generally, you can imagine a unit mass of consumers with any number of possible values, as long as they're finite. Now we can define coalitions. A coalition is just a subset of consumers. So in this example, I'm showing you two different coalitions. Coalition 1 contains consumers from 0 to 0.3 and consumers 0.7 to 1. Coalition 2 contains consumers 0.3 to 0.7. Now you can define for every coalition of consumers what surplus they would get. And their surplus is once the seller offers a profit maximizing price for that coalition, what would the consumer surplus be? I should have also said that we're going to normalize the cost of production for the seller to 0. So the seller basically offers a revenue maximizing price for each coalition. So you'll see that in this coalition, coalition 2, there is a higher measure of value 2 consumers than value 1s. Therefore, there's a unique revenue maximizing price that is 2. Therefore, the surplus of all consumers in this coalition will be 0. If there are segments, they'll get a price of 2 and their surplus will be 0. You'll notice a minor issue here, which is that for this coalition, there's an equal measure of consumers of values 2 and 1. There's 2 revenue maximizing prices for the seller, 1 or 2. So we have to be precise about what exactly the seller is going to do. So to be careful about this tie-breaking issue, I'm going to define a segment to be a coalition price pair such that that price is revenue maximizing for that coalition. So there are 2 possible segments involving C1. It's C11 and C12 because both prices 1 and 2 are revenue maximizing for coalition C1. But on the other hand, C21 is not a segment because price 1 is not revenue maximizing for coalition C2. The unique revenue maximizing price is 2. So by defining segments this way, I will be explicit about what exactly the price that is chosen for that coalition is. Now we can define a segmentation. A segmentation is a set of segments, meaning a coalition and price pair such that that price is revenue maximizing for that coalition, such that these coalitions collectively partition the set of all consumers. This is exactly how you would imagine a segmentation. You partition consumers. For each coalition, there is going to be some revenue maximizing price. Now we can define the surplus of each consumer in this segmentation. So for consumer C, little c, that is in coalition C1, the surplus they get is maximum of their willingness to pay -1, because they're going to get a price of 1 in that segment, and 0. They may choose to not buy. So for example, consumers who have value 1 are going to get a surplus of 0. Consumers who have value 2 are going to get a surplus of 1 because the price is 1 in this segment. Consumers who are in coalition C2 are going to get a price of 2. Therefore, their surplus is going to be 0.
Nima, I have a couple of questions here, and I think this is a good point. So the first one is by Heskey. He's wondering about multiplicity of stable coalitions. So are there going to be multiple stable coalitions? And if so, do they generate different surplus?
Absolutely. So we haven't defined the solution concept yet, but to preview, yes, there will be multiple stable segmentations, and they will involve different consumer surpluses. But that's where we're basically going to get to. It's a bit too early to answer that right now.
Okay. Dan Savell is wondering, or is asking, is the underlying idea here that there is an intermediary firm that exists for any segment that wants one? And if these intermediaries exist, would it be possible for one to force maximum consumer surplus through segmentation and then allocate gains so everyone wants to join?
Absolutely.
And Heskey has a follow-on comment. I guess like Dana he was trying to think about the process through which such a coalition could come about and whether that helps with selection in the case of multiplicity.
Excellent. So these are excellent questions. So yes, one way to think about this is that for each possible coalition, there is an intermediary. So for students, there's an intermediary that they can go to, and that intermediary will serve between those students and the seller. So this is one way to think about it. You're not going to imagine that you can force these intermediaries to partition consumers in certain ways. You're going to allow for intermediaries to form objections. For example, if this is a segmentation, you're going to say, well, what if there is an intermediary who could step in and attract some of these consumers and allow them to benefit? And finally, you're not going to allow for transfers. So this is just a modeling decisions we have made, which is that you're not allowing for transfers between consumers. So this is going to be a non-transferable utility game. If we had a transferable utility game, that would be absolutely correct, that the resulting segmentation would maximize average consumer surplus and then will redistribute the surplus between consumers. We're not going to assume transfers, and therefore it's not necessarily going to be maximizing consumer surplus.
Elliot Lipnowski is asking, is it without loss for each segment to get a single price rather than a stochastic price? One could imagine mixing would help maintain simultaneous incentives for distinct consumers within a segment.
Good question. We did not think about it. So let's just assume that there's a deterministic price for each segment. I believe, I'm happy to discuss it later, that things are going to be fine even with stochastic prices. Maybe we can, if I remember, I'll discuss it when we get to the characterization of stability.
And the last question by Larry White, has arbitrage been ruled out?
What does that mean? I'm not sure I understand.
Larry, you want to clarify?
Sure. Just, the segment that gets to buy at a price of 1, you're ruling out the possibility that they can turn around and sell at a price below 2 to the second. You've ruled out arbitrage.
Absolutely. So there's no resale, there's no such opportunity. Yes.
Okay.
Cool. Thanks for the question. So I think many of these, Bernard, is there more? Okay, good. So many of these questions is basically where I'm going to go. So the question is now, what segmentations are stable? I haven't defined stability. Just at a high level, we want to understand if for a given segmentation, there would be some coalition of consumers who could benefit from forming a new segment. And that's where I'm going to go. There's going to be preview. There may be multiple. So I'm going to start by defining the core first. That basically allows for all possible objections to a segmentation. We're going to see that there's going to be an issue with the core, which is that the core is generally empty. So there's no segmentation that is immune to all possible objections. That's why we consider this not a satisfying solution concept. We will define a new solution concept, which we call stability. As far as we know, this has not appeared in other cooperative solution concepts. And we're going to see that this solution concept is always non-empty. So there always exist stable solutions, even though they're going to be multiplicity. Good. So what's the core? I'm going to define it formally, and then we're going to go back to our example. Basically, the core says a segmentation is in the core if there is no coalition of consumers who could benefit by forming a new segment. This is what it means formally. We say that a segment objects to a segmentation if the surplus that they could get by forming this segment, the surplus that they would get is there for each consumer is value minus price, maximum of that and 0, is weakly higher for all consumers in this segment, in this coalition, and strictly higher for some consumers in this coalition. So we're saying nobody in this coalition should be harmed, otherwise this is not an objection, and somebody, a positive measure of consumers in this coalition must strictly benefit so that there is some incentive for forming this new coalition. You may ask, well, why do I define it this way? Why do I not ask this to be strict for all consumers in this coalition? One answer is that if I define it with strict inequality for everybody, then there is no objection to anything. Why is that? Because consider any segment, CP. Somebody in that segment must be getting 0 surplus because the price is never lower than the lowest value in a group of consumers. So that type whose surplus is 0 cannot be benefiting by joining this new segment because the surplus is 0. 0 is not higher than anything. So we define it this way so that there are some objections to some segmentations. And notice further that by definition, an objection is not already a segment of a given segmentation, because if this segment was already in the segmentation, then no consumer surplus would strictly benefit. And then we define a segmentation to be in the core if and only if there is no segment that objects to that segmentation. So I'm going to go back to my example and show you that, okay, so let me show you the result first, which is that the core is generally empty, and then we go back to example. The core is generally empty in this formal way. There are two possible cases. If V1, remember, V1 is the lowest possible value in the set of all possible values. If V1 is not revenue maximizing for the coalition of all consumers, then the core is empty. If V1 is revenue maximizing for the set of all consumers, then there is a segmentation in the core. And in fact, there is essentially a unique segmentation in the core. So let me explain why these two conditions are same. The second one is the easier one. Let's suppose that if the seller was choosing the revenue maximizing price for everybody, one revenue maximizing price is to charge the lowest value. Then you could see that the segmentation, that the trivial segmentation that puts everybody in one coalition and the price is V1, there's no objection to this because every consumer is paying the lowest possible price they could be paying in any segment. There is no segment in which the price is lower than V1. Therefore, there is no objections, and this segmentation is in the core. And in fact, we can show this is essentially unique. It could be, could split it into two identical pieces. It's technically not the same, but everybody gets the same surplus. the meat of this proposition is in this other case, which is that if V1 is not revenue maximizing for the coalition of all consumers, then the core is empty. And the idea is that, well, if V1 is not revenue maximizing for the coalition of all consumers, then in some segment, the price has to be above V1. Then some consumers who are excluded can form an objection and attract some consumers who are paying a price higher than V1 together with them, and this would be an objection to the resulting segmentation. And let me tell you what the interpretation is. I interpret this as saying that the core is often empty. Why? Because V1 being revenue maximizing for the set of all consumers is a non-genericity condition. Among all possible values, it just happens that V1 is a revenue maximizing price, the allocation is already efficient. In most interesting cases, V1 is not revenue maximizing for everybody, and in this case, the core is empty. So I'll go back to our example to see what is exactly the issue with the core. So let's go back to our example. And let's suppose that we're considering this segmentation. Consumers from 0 to delta, where delta is some number less than 0.8 are in coalition 1. Consumers delta to 1 are in coalition 2. Because delta is less than 0.8, a revenue maximizing price for coalition 1 is price 1. And because coalition 2 contains only type 2 consumers, revenue maximizing price for coalition 2 is 2. It's easy to construct an objection to this segmentation. What is that objection? Well, some of these, a very small fraction of these consumers from coalition C2 can join coalition C1. Because delta is less than 0.8, as long as this measure is small enough, price 1 remains optimal for coalition C1. Price 1 is not going to increase. Therefore, these consumers are happy to join this objection. Their surplus would not decrease. And the surplus of these consumer 2s who are joining would strictly increase because their price goes down from 2 to 1. So there is an objection to this segmentation. You can do this until delta hits 0.8. At this point, you cannot add any more value 2 consumers to this coalition because now the price in coalition 1 is going to go up. So these consumers are not willing to be a part of this objection. Remember, for an objection, everybody's surplus must be weekly increasing. Nevertheless, I claim that there is another objection to this segmentation. What is that other objection? Well, instead of these consumers joining this coalition, they can steal value 1 consumers from the first coalition. So some of these consumers can get together with all value 1 consumers and form an objection. This, for example, would be such an objection. All the value 2 consumers who are currently the pay price of 2 would join an objection with consumers of value 1. This is an objection because consumers of value 1, they don't care. Their surplus is 0 regardless. And consumers of value 2 is strictly benefit. So this basically shows you what the issue with the core is. Whoever is paying a high price can steal the low value consumers and therefore reduce their price. And this would be an objection. That's why core is generally empty. But you will see that there is something fishy about this objection, which is that after if this objection is successful, then these value 2 consumers who used to pay a price of 2 now will end up paying a price, they used to pay a price of 1, now they pay a price of 2. So their surplus goes down. So C1 would itself be an objection to the resulting segmentation. So even though there is an objection to this segmentation, there is already an objection in the current segmentation to the resulting segmentation. And if consumers with value 1 are forward-looking, they may not be willing to be a part of this objection because they understand that if this objection is formed, it's going to be blocked back by the original segment. And this is exactly our notion of stability that I'm going to formalize in the next slide. There's a bunch of questions, so I'm happy to stop here.
There was a question by Heskey, which I think is better suited for the Q&A. It goes a little off tangent.
Okay, cool. All right. So let me define exactly what stability means, and then we discuss. So here's stability. We say a segmentation S prime blocks a segmentation S if segmentation S prime contains some segment that objects to S, but S contains no segment that objects to S prime. So basically, S prime is objecting to S, but there's no collision, no segment in S that would object back to S prime. And we say that S is stable if there exists no other segmentation that blocks S. I'll go back to my example and show you, in that example at least, that a stable segmentation does exist. And one of our results is going to be that in general, stable segmentations do exist. So let me show you why this segmentation is stable, even though it's not in the core. Okay, so notice that these consumers are getting the best possible surplus they can get. They're getting a price of 1. There's no way they can get a price lower than 1. And in some sense, these are the maximal measure of consumers of value 2 who can get a surplus of 1, because there's only 0.4 measure of value 1. So therefore, the consumers of value 2 who could get a price of 1, their measure is at most 0.4. So if you give me any other segmentation in which some of these other consumers are getting a price of 1, that means that some of these consumers must be getting a price of 2. Therefore, this coalition would object to any other segmentation. Therefore, no other segmentation would block this segmentation. So this segmentation is stable versus the other segmentations that I started with, where delta was less than 0.8. These are not stable. I can point at another segmentation that blocks this segmentation. For example, our original segmentation blocks this segmentation because S contains a segment that objects to S prime, but S prime contains no segment that objects to S. So what is left to do is to do 2 things. I will characterize what stable segmentations are. I know that you would like to see existence first, but to prove existence, we're going to go through the characterization. So we're going to characterize what segmentations are stable, and then we're going to use this characterization to prove that stable segmentations exist. And then we're going to compare them to other things. For example, consumer surplus maximizing segmentations and such, using this characterization. So the characterization is this. It also contains 2 parts. The first statement says that if you want to know if a segmentation is stable, convert it to what we call its induced canonical segmentation. I will be precise what this means, but you can basically convert that to a canonical segmentation and then check if that canonical segmentation is stable. How do you check if a canonical segmentation is stable? It is stable if and only if it satisfies 2 properties, efficiency and what we call satiation. So let me define these terminologies. First of all, what is a canonical segmentation and what is the induced canonical segmentation? Notice that an arbitrary segmentation may contain 2 different segments where the price is the same. One segment where the price is 5 and another segment where the price is 5. If you merge those 2 segments, the optimal price does remain 5. So nothing really changes if you merge those two segments together. So this is basically what we call the induced canonical segmentation. Take all segments that have the same price and merge them together, we call this the induced canonical segmentation. And it's canonical in the sense that no two segments now have the same price. Every two segments have different optimal prices. So this is a canonical segmentation. So step one is give me a segmentation. Convert that into a canonical segmentation by merging all segments that have the same price. Then you can verify if it's stable by checking efficiency and satiation. Well, efficiency, it should be easy to understand, right? Efficiency basically says that for each segment, the price is equal to the lowest value in that segment. Therefore, everybody is served. Remember, we have a normalized cost to zero. Everybody being served is efficient. Then there is satiation. This is really the new concept. The idea is that we call a segmentation satiated if you can't take some consumers from some segment where the price is high, add them to a segment where the price is low without increasing the price in the lower priced segment. Notice that if you could do this, our segmentation is clearly not stable. I have added some consumers from some segment where the price is high to one where the price is low without changing the price in the low priced segment. So therefore, this would be obviously an objection to which there is no counter objection. So this would be necessary for stability. They basically, the meat of this result is that this is also sufficient together with efficiency. If you have a segmentation that is efficient and is satiated, then there is no other segmentation that blocks this segmentation. Basically, all you need to do is to check for very simple kinds of objections where you will take some consumers from a high price segment, add them to a segment with a lower price without changing the price in the lower price. I have formal definitions here. I'll be a bit quick going through them. We defined canonical segmentations with no two segments have the same price. We talked about induced canonical segmentation, and we defined efficiency and satiation. And we basically said that a canonical segmentation is stable if and only if it is efficient and satiated. So the picture so far looks like this. There is a core which may or may not exist, but if it does exist, it's essentially unique. There is stable segmentations, which is a superset of the core that we characterize as efficient plus satiation, may or may not be empty as far as we know so far, because all we know is a superset of a possibly empty set. And then there is the set of efficient segmentations. Efficient segmentations always exist. For example, perfect price discrimination is an efficient segmentation. If each consumer is in a different segment, then the allocation is going to be efficient. So the question is now, how do we use our characterization to show that stable segmentations exist? And I will start by constructing an algorithm that for any environment gives us a stable segmentation by basically showing that that algorithm gives us an efficient and satiated segmentation. Some of you may have seen something like this before. Just as an overview, it's going to be one of the segmentations that discussed in Bergman, Brooks, and Morris. So I'll go back to talking about examples. Let's consider this instance of the problem where now we have three values, 1, 2, and 3. The measures are 1/3, 1/6, and 1/2. I will construct this segmentation that I will argue is efficient and satiated, and therefore it is stable. Segment 1 is an equal revenue segment in the sense that in segment 1, price 1 or price 2 or price 3 are all revenue maximizing for the seller. Just measures are just exactly set up in this way. And furthermore, segment C1 is the maximal possible such segment, meaning it contains all consumers of value 1. You cannot make it any larger and still make sure that all three possible prices are up. If you add any more consumers, that has to be either value 2 or 3, and the price is going to go up to either 2 or 3. So this basically means that any consumer that is not in C1, if I add it to C1, that has to increase the price from 1 to something else, because the added consumer is going to have value either 2 or 3, so that's going to increase the price. So C1 is satiated. Now we can basically iterate over the same process. We can say, well, among the remaining consumers, which have either value 2 or 3, I'm going to find the largest segment in which all possible remaining prices, 2 or 3, are optimal. I'm going to let C2 be that. That's going to look like this, just ugly numbers. But basically, the point is that the prices 2 and 3 are both revenue maximizing for this coalition. Then again, this means that if I add consumers from C3 to this coalition, the C3 consumers have value 3. If I add it, the price has to go up because both prices 2 and 3 are revenue maximizing in this coalition, which means that coalition C2 is satiated. We already argued that coalition C1 is satiated. Therefore, this segmentation is satiated and it is efficient. For each coalition, I can choose the lowest price as the price in that segment. I get efficiency. So I have constructed a segmentation that is efficient and it is satiated. Therefore, by a characterization result, it is stable. And notice what our characterization is now saying. It's saying that once you make sure that such deviations don't exist, that some consumers would want to join a lower price segment, then there's no other possible blocking segmentation. All possible other segmentations where consumers could just rearrange in arbitrary ways, no such segmentation would block this segmentation. And this is the content of that main characterization result. So what I will do next is to basically generalize this algorithm to an algorithm that always constructs a stable segmentation. I will call this maximal equal revenue segmentation, thereby proving that stable segmentations always do exist. I will be a bit quick given time constraints, but basically the idea is the same. You will start by putting all consumers in a set C, a set C bar, and then let the first segment be the largest coalition where all prices are revenue maximizing. This is C1, you take it away. Now you iterate. You let the next segment to be the largest coalition where all remaining prices are revenue maximizing, and you keep doing this until you run out of all types. This algorithm gives a satiated and efficient segmentation and therefore a stable one. And as I hinted at before, this is one of the segmentations that Bergman, Brooks, and Morris prove that maximizes the average consumer surplus over all possible segmentations. But this is not the unique such segmentation. There are other segmentations that also maximize average consumer surplus. So now you may ask, well, what is the relationship between stability and maximizing consumer surplus? We already argued that there is one segmentation that is in the union. There is one segmentation that both maximizes consumer surplus and is also efficient. What we're going to show next, and this is going to use our results, is that these two sets are neither of them is contained in the other one. So stability does not necessarily mean maximizing consumer surplus. Maximizing consumer surplus does not necessarily mean stability. So to show you this, I will have to basically just show you two examples. One, a stable segmentation that does not maximize consumer surplus, and another one that does maximize consumer surplus, but is not stable. So the first one is easier. I will show you a stable segmentation that does not maximize consumer surplus. Here is that segmentation. Well, the environment is that there is an equal measure of values 1, 2, 3, and this is my segmentation. Consumers 1 and 2, all of them are in coalition 1, and consumers 3 are in coalition 2. The price for coalition 1 is 1 because there is an equal measure of value 1 and 2s here. And the price for coalition 2 is 3. Notice 2 things. This segmentation is efficient. Everybody, the price in each segment is the lowest value in that segment. And it is satiated. You cannot add any value 3s to the first coalition without increasing the price in the first coalition. Because if you do add value 3s to the first coalition, the revenue maximizing price is no longer going to be 1, it is going to be 2, as long as this addition is small enough. So this segmentation is stable, but it does not maximize consumer surplus. I can show you another segmentation that has a higher average consumer surplus. I can show this to you by basically constructing a marginal improvement, another segmentation that is marginally better than this segmentation. What is that? Well, what if we can take some consumers of value 3 from this segment, add it to the first segment, and in exchange, remove some of the value 2s of the same measure and put it in the second segment? What's going to happen if we do this? If these 2 measures are equal to each other, price 1 does remain revenue maximizing for the first coalition. So the benefit of these consumers of value 3 who are joining the first coalition would be their surplus goes up from 0 to 2. They get a unit of 2 per consumer benefit. But the ones who are losing some surplus, their surplus goes down from 1 to 0 because they were getting a surplus of 1 here, but now they're going to get a price of 3 and their surplus is going to be 0. So the benefit per consumer, which is 2, is larger than the loss per consumer, which is 1. So this on average increases consumer surplus. So stability need not mean that consumer surplus is maximized. Now I will show you the other direction, which is that maximizing consumer surplus also does not mean that the segmentation is stable. So let's go back to this example that we had. There's again 3 possible values, 1, 2, 3 with these measures. And trust me that this segmentation that I'm showing you maximizes average consumer surplus. The argument, it's not super easy. This is basically what other papers have shown, so I'll just take this, that this segmentation maximizes consumer surplus. And I will show you that this is not stable. Why is it not stable? Because it is not satiated. So in the first segment, the optimal price is 1, but price 3 is also revenue maximizing for the seller. In the second segment, the optimal price is 2. Now, this segmentation is not satiated. Why? Because I can take some consumers of value 2 and add it to the first segment. This is not going to increase the price. The 2 optimal prices for the seller in the first segment are either 1 or 3. If I add a small measure of value to consumers, price 2 is not going to become optimal because these are so small. And price 1 becomes relatively better than price 3 because now a bit more consumers will buy price 1, but no extra consumers are going to buy at price 3. All these additional consumers that I have added, they don't buy at price 3. Therefore, price 1 remains optimal for the first coalition. So this means that this segmentation, even though it maximizes average consumer surplus, it is not satiated, and therefore it is not stable. So I will basically start wrapping up soon. I will discuss some related work first. So our work is related to several different literatures. The first one is trying to understand markets, basically coalitional foundations of markets. There is very, very, very old observations going back to Edgeworth that says basically you can think of the connection between the core and competitive equilibria of exchange economies. This is formalized more in the Brewer and Scarf. There's also work by Shapley and Shupik trying to understand the coalitional foundations of markets. And a notable new paper in this strand is Peyvandi and Vora, where they study stable mechanisms, meaning what mechanisms would be immune to being fragmented, meaning different groups of consumers would form different, would join different mechanisms. So this paper only studies fragmentation of the markets and does not study what happened when different groups of consumers can join. And also they're discussing stability of mechanisms, not stability of segmentations. As I said, there is a large literature in third-degree price discrimination. This literature typically takes as given a segmentation and wants to understand its properties. When does it increase or decrease consumer or total surplus? There is a more recent literature on information design. Notable papers are Bergman, Brooks, and Morris. They're not taking a stance on where do segmentations come from. They're just trying to say, well, let's imagine all possible segmentations and let's try to understand what is the possible consumer and producer surplus pairs in all possible segmentations. A bit closer to us are papers that study segmentations that maximize average consumer surplus. This is Ichihashi's paper and Hidiro and Velodi. So you can also think of these papers as basically saying what segmentations would consumers choose. But this would be an ex ante view. Basically, these papers are saying, what if before consumers realize their types, they could choose a segmentation? Well, if we don't know their types, we all have the same preference over segmentations. We just want to maximize the average or the expected consumer surplus that we would get once we realize our types. So this is an ex ante perspective to segmentation. For example, we could say, well, what would a regulator do? A regulator, if they just want to maximize the average consumer surplus, then this is what they would do. We are taking an exposed perspective, saying, well, consumers very often do know their types. So now they may have different preferences over different segmentations. What is going to be the resulting segmentations, or what kind of segmentations are going to be stable? They're going to be immune to objections by groups of consumers. Finally, you may ask, well, why did we have to invent this new notion of stability? There's many other solution concepts that the cooperative game theory literature develops. The short answer is that we may not know all possible solution concepts, but the ones that we do know, we have tried and they don't work. They don't work in the sense that all these solution concepts are going to give you something trivial. Either everything is in that solution concept or nothing is in that solution concept. That applies to bargaining set, kernel nucleolus, stable set, and so on. So in order to get a solution concept that is not trivial, we're going to have to develop this new notion of stability. I have some slides on discussing a little bit more detail, in particular what bargaining set means in our example. I'm happy to discuss that after the talk. I have one slide before I start concluding. Let me offer an alternative way to think about our paper. And that is as a model of price competition with identical products. As Bernard hinted at the beginning of the talk, I could also think of our model as having multiple sellers. For example, in this segmentation, I can imagine that coalition C1 goes to seller 1 and coalition C2 goes to seller 2. All that matters is that each seller will offer a revenue maximizing price for that coalition. So you could imagine that there's many sellers out there. We join coalitions and each coalition goes to a different seller. So if there's 1,000 coalitions, they're going to go to 1,000 different sellers. So in this sense, we can think of this as a model of price competition where consumers first choose which sellers to buy from, and then the sellers choose prices. These sellers are identical. So all that matters when we're talking about which seller to buy from is what coalitions are going to buy from the same seller. And in this sense, this is going to be an upside down version of a Bertrand. In a Bertrand game, sellers choose prices first, and then the consumers choose which seller to buy from. Whereas we are saying consumers choose which seller to buy from, and then the sellers choose the optimal price. And the difference is going to be that whereas we saw that segmentations are stable, stable segmentations are efficient and involve price dispersion, in Bertrand you get efficiency but uniform prices. So notice there's a big difference when I say consumers choose here and consumers choose here. In Bertrand, when a consumer is choosing who to buy from, they only need to think about the different prices that the different sellers are offering. There's no externality amongst consumers. Whereas in our setup, there is this externality, which is that the price that you do get as a consumer depends on who else you form a coalition with, because that's going to affect the price that you get as a consumer tomorrow. So let me conclude. What we asked is, what happens when consumers can collectively choose segmentations? We discussed two solution concepts. We said that the core is often empty. That's why we developed this new solution concept of stability. Show that stable segmentations exist. They are efficient and satiated. And this characterizes all stable segmentations. May or may not maximize consumer surplus, although one of them does, and involve some degree of price dispersion. Different coalitions may end up paying different prices. I'll stop here with this picture. You will see that there's some concepts that I did not discuss, like the fragmentation proofness and Pareto undominance and such, but this is, I'm happy to discuss these concepts, the relationship of them with our notion of stability. But this is basically what we have. Thanks for listening and thanks for being here. I'm happy to answer questions or discuss.